Yes, sounds
Okay,
good.
great.
All right. Thank you for the introduction. I want to say special thanks to Mel and Matt and Jim. Y'all have kind of facilitated this, at least on my side. So thank you. And good afternoon, everyone. Again, thank you, IADD in general, for the opportunity for me to present how Smith Bits technology can enable step changes in performance for our customers. So far, lots of great topics covered so far, and great questions and great discussions. Paul, Gabe, and Dustin actually did a fantastic job setting the stage for this particular case study, unbeknownst to them, promise. So I'll just thank them right now. They touched on many drilling challenges that Smith Bits had been addressing for years, wear on fixed cutters, mitigating impact damage, and understanding how different cutter geometries engage various formations. It's something that's very central to where we're at as a company right now. So um, Smith has the most diverse and widely used portfolio of unique cutting element technologies that allow us to deliver step changes in PDC bit performance. By implementing these novel shapes into our PDC cutters, we can provide additional utility when compared with flat cutters. And for instance, Hyperblade, that concave shape you see there basically improves the cutting efficiency in soft formations. With the EnduroBlade 360, it's basically the wear mitigation. So we've long understood that nothing cuts better than a sharp cutter, and by utilizing the entire edge, we're able to really take advantage of that whole entire cutter. With Stingblade, a conical element provides a superior impact strength in the high impact prone applications. And for AxeBlade, which we'll focus on for this presentation, that ridge shape does deliver a concentrated point load into brittle rocks such as carbonates to create some plowing effect and increases cutting efficiency that way. So the journey of the entire kind of 3D market started with Smith and back in 2013, and AxeBlade specifically started in 2016. And really, oh, did I lose you guys? Hello? Sorry, my
We can still
computer
hear you.
glitched. Oh, okay. After analyzing thousands of dull cutters from the AxeBlade, Axe Ultra was then commercialized in 2020, and while it uses the same external geometry as the Axe cutter, the improvements that were made further reduced the cutter damage. Basically, the two damages that we were seeing were ridge spalling and wear, obviously. And so it's important to understand the approach taken in the development of all of these different products is similar to one we would take with any other PDC cutter, whether it was just 2D or 3D, all in the effort to extend the run lengths and improve the overall ROP and ultimately deliver wells faster for our customer. So Rockcliff has been a fantastic performance partner with Smith for years. We've set a lot of records with with our products with Rockcliff, and it's been a great learning partner as well. As new technologies tend to come out, they shape and they reshape the applications, creating new ones or obsoleting old ones. So because of our strong relationship here, it was only natural for us to bring them our newest next gen 3D shape for testing in one of their most challenging applications. A few other presentations here seem to have been from the kind of East Texas basin. So this is another example from that same basin, right? So the application is the 9 7/8 drill out interval in the Haynesville Basin, and it starts around 1,000 or 1,600 feet. Casing points just over 10,000 foot, and the challenge here is drilling all of this complex, challenging lithology in just a single bit run. And there's a lot of directional requirements here. The first portion of this section is through a heavily interbedded limestone, shales, and hydrites, and that's a lot of instability and high impacts due to the transitional drilling, and also the UCS of these, the unconfined compressive strength of these formations tend to range from really low in the 2s to what we've seen up in the 25,000 psi range, and so you get these massive changes in formation strength, and those along with the interbedded lithology tend to have cause a lot of vibrations. So often directional work is started in that upper section of the hole, and it's generally faster than the sand section below. And those tangents can get up to 15 degrees, and those tangents can be held all the way down to kickoff point, just past 10,000 feet. And the second portion of the section are various hard abrasive sandstones. Some were mentioned, Travis P, Cotton Valley, and they combine not only the high impacts due to the formation compressive strength, but also now with abrasion, as those sandstones are pretty angular and highly cemented. And so again, the tangents are held through these intervals as well. And so steering and rotating in these, alternating those two drilling modes tends to really to make it a challenge for these drill bits to drill limestone first, and then drill these sandstones. So the penetration rate, as it hits that sandstone, is the main reason for not reaching casing point. They'll sustain some damage in that limestone and the carbonate, sustain some cutter damage, and then when it gets to the sandstone, it kind of is chipped through that leach layer. And once that leach layer is chipped through, then the cutter experts are on the line here, and hopefully they'll agree. But once you get through that leach layer, then all bets are off. That cutter is going to thermally degrade very quickly. So it's surviving to the sandstone with an intact cutter is paramount to getting this section drilled in one run, right? So so these high impact environments are actually where the axe geometry really shines. And in the chart here, I'll go to the chart. I'll start talking about that. The axe cutter does outperform the next best competitor in terms of footage at a similar ROP, but that's getting into the sandstones there. Axe Ultra further improves that impact resistance and thermal stability, as I mentioned earlier. So naturally, there is an advantage over the axe, where the footage seen here, where the footage is higher, and the ROP is a little, it is still very similar, 97 versus 101 foot an hour. So I'll pause here, and I'll ask myself, and I'll answer it. A question here is, why did we elect to run these next gen cutters in this application? Well, on the bottom left, we have some cutter scrape tests that we perform in-house, and we can do this with any cutter size, shape, bevel, back rake, side rake, these sort of things. But there's a very, very clear increase in cutting efficiency in both medium to hard limestones and medium sandstones. And it's kind of weighed more toward efficiency in that limestone. So 28 and 12% respectively, right? Limestone versus sandstone. So that's the reason that we actually applied this cutter in this application. So finally, I'll go to the far right bar here. The next gen 3D shape combined the best parts of the axe geometry with its impact and wear resistance, and adds increased cutting efficiency, basically in the same formations that it shows more efficiency versus the axe cutter. So it just made sense to put it here. And the application of that 3D cutter technology culminated in the operator's best performance to date. So we're very proud indeed of our kind of combined achievement. It definitely wasn't all Smith bits here. It's what we as service providers strive to attain when we partner with our customers. There's a lot of examples of that today, but I'll go ahead and turn it over to Kyle. So let me introduce Kyle and let him take it from here.
I would say just kind of a great example of what you were just talking about would be looking at your Axe Ultra compared to your next gen. I mean, you could have just stopped right there at the Axe Ultra since drilled more footage at a faster ROP, right? But I think the goal, if you talk to any drilling engineer in Haynesville, whether it's East Texas or North Louisiana, it's how do we get to TD and with one assembly? And I've seen people stay in the hole for 2 weeks drilling 15 foot an hour to do so. Well, I'm not one of those guys. I know when to pull it out, but I think one of the difficulties as a drilling engineer is if you are in an area where you don't think you can one run an assembly, it's our job to find that optimal pull point. There's economics that goes into that. There's offsets that you need to look into, but sometimes you don't find, if you're on a full well pad, and you might not figure out what that optimal depth is until the second or third, or heaven forbid the last well. So anything we can do to eliminate trip, we would love to do, but there is some people on the other side of the coin. There are a lot of people who stick with, it kind of has to do with your ROP threshold. Like sometimes we get under 30 foot an hour, and we say, okay, that kind of tells us that our bit's worn out, we need a trip. That tends to change not only with the operator, but drilling engineers within the same company. So I think it's just kind of a collaborative thing that we've worked a lot with all of our bit manufacturers have come up, because it's not just the bit technology, right? It's let me pull up my screen and see if I can share it. I'll show you something that we put together.
Here, I'll stop sharing
Let's
here.
See. Yeah, I think I might have to take it from you. Okay, let's see if you can see this. Don't lose y'all. Can you see that?
Yes, we can see your screen.
You can see the roadmap?
Yes.
Okay, so this is a perfect example. It's actually for, I couldn't find my 9 7/8, which were the 3 good runs that we had to TD where we one ran. But this is a good example of something that we actually, I mean, this doesn't happen overnight. It's over the course of multiple runs and some modeling. You can see those columns there. So this is basically just a drilling parameter roadmap, is what I would call it. And you have your as drilled run parameters shown in the columns, kind of in the bottom left. Can everybody see that, or should I zoom in a little bit more? I won't let me zoom in. But to the right, you can actually see formation, lithology, and
You may want to zoom in just a little bit.
what? Zoom in just a little bit.
Yes.
There you go. So,
Yes, that's better.
right. This is great. I mean, it actually shows lithology, some of our tougher spots. There's a lot of areas in which we really just want to back off temporarily, like maybe 100 feet until we get into transition zone, until 100 feet until we're past it. And what we do is, you know, the driller, the guys on location will put specific instructions. So we have our main road maps, and these are kind of like our sub road maps. And it says, once you go through this TVD, thou shalt, you know, take the flow rate down. And usually we're backing off parameters, not ramping them up through the transitions. And then once we're through them, we can ramp it back up to the normal parameters. But honestly, it's been an empirical battle, just getting bits in the ground, figuring out what they're going to do. This one, for instance, no one thought we could spin a 13.5-inch bit at over 200 bit RPM into the Travis Peak. And we found that was actually the optimal way to do it. And even with some heavy weight, up to 40K on it. And we came out with plenty of 1-1s. So kind of don't know until you press the limits and try. But my whole point of this is that, you know, you've got bit technology. If you've got an engineer that's willing to work with you and follow up with you after runs, I think some of even the cutter technology itself feeds into this too. BHAs, I like to get everyone involved in the conversation, including the guys in the field. So not only do we come up with a good plan, but one that's everyone agrees upon and they actually understand out in the field. I know I'm kind of speaking generically here, but I'm sure you probably all work with some drilling engineers who are like that and some not so much, right? If I had to guess. But it does help putting these roadmaps together. And I really don't think if we had not perfected them, then don't get me wrong, the bit technology is great. The new gen cutters are good. But I think you really do need the combination of solid drilling parameter roadmap plan and a good BHA plan as well. And I think when you get all 3 of those things, I mean, that's where you get success in those 1 runs. And there are certain fields in which you are never going to 1 run, unfortunately. Well, maybe one day, but you know, we do have some harder stuff that we drill. So certain areas are more prone to being able to 1 run than others. I will say that. But maybe not for long. I mean, is from what I mean, I'm thinking back 10 years ago, and we didn't used to pull bits until they got under 20 foot an hour, and now our threshold's 40 foot an hour. So regardless of what bit we're running, technology is getting better. And I think at some point we will want to run these sessions. But to let everyone know, a round trip and intermediate, I mean, it's not as costly as a production section trip, but you know, it might cost us 50 grand on the operator's side. So that's always something we're trying to avoid. And with this type of cutter technology, it helps us avoid that economic hit and also get from spud to TD faster. Kind of said a lot there. So I'll pause for any questions or feedback. Hopefully I'm not on mute.
You're not on mute. We need you to repeat all of that, please. I'm just kidding. Okay, thank you, Kyle. We appreciate it.
Yeah.
All right, open up for questions. Does anybody in the room have questions? Ah, all that data that was shared.
Ask him a question.
Yeah, and he shared so much. Crickets.
Okay, what do they look for as far as partnership between the big companies and the direct?
Our famous David Gibson in the room asked, what do you look for as far as partnership with drill bit companies and directional companies?
From a drilling engineering side?
Yes.
You know, whether I know that person or not, it doesn't matter. I think if I meet somebody and usually it's facts. There's a lot of, you know, the slide was up earlier, all the text, the know-it-alls. I know everything, the technical experts, everyone thinks they're one. I don't think any engineer likes to just be told my bit's the greatest, you should run it in the hole. So I think every drilling engineer appreciates, you know, facts, whether it's big bit records or a case study or bit runs in the area. It's kind of a nonchalant way of, especially if you don't know the drilling engineer, to kind of introduce yourself and say, hey, we just had this run in the county over from you. You know, obviously don't need a commitment from you, but just wanted to get in the door, put this in front of you. To be honest, unless someone's really busy, we do get around and check that stuff. We review all that stuff, and we've got bits going in the hole tomorrow because of that. So I'm not like every drilling engineer. I'm not saying I'm better or worse, but yeah, they all have their own personalities. There's people that will run one manufacturer. There's people that will do kind of the opposite, like what I do. I spread the wealth around. I know a lot of people on the bit side, and I'm not just trying to help them. I mean, everyone attending this has good products, right? So I don't know if that answers your question, but the collaborative part, like at a minimum, after a run, especially if it's anything worse than a 1-1, I always expect without asking that the bit manufacturer will come back and somebody will send me some type of post-run analysis. You'd be surprised how often I don't get those unless I request them. Really, we should be getting them for good runs too, or decent runs. I mean, obviously if it's a pace setter, I'm sure they'll put it together, but what we need to know is if we have a 2-3 with normal drilling parameters in whatever section, as drilling engineers, we don't, you know, we get, not only do we need to know what happened, but, you know, a lot of times that question works its way up the ladder. So my boss asks me, what do you think we did to this bit? If I don't know, that doesn't look very good on me. I always have my suspicions, right? But if I don't have the facts, it really helps to have those post-well reports ahead of time. Same thing goes with pre-planning too. I mean, I'm just starting to look at my next pads. We're still 2 to 3 weeks out, but I like to get the directional plans in front of all of the bit providers well ahead of time. That way we have a lot of different directional work, some uphole, some downhole, and some of their bits, some companies' bits are better for different applications. So instead of just asking them a day before, hey, what do you think would work in this section? It gives them a couple weeks to, I don't know if you're getting that stuff a couple weeks from all engineers ahead of time. I doubt it, but I try to make life easier on y'all because y'all make life easier on me, if that makes sense.
Yes. Well, thank you. Any more questions?
I'll add one last comment if I can. You know, we keep talking about this next gen shape in I think in October. I think Schlumberger is having some kind of online technical conference, and they're going to commercialize it at that point. So y'all will be able to see it at that point. So that's all I got.
Thank you. We appreciate it.
Thank y'all.
All right. Moving on to our last presentation.